Hey, YouTubers, Tazman here, bringing you another episode of Taz Teaches Java. Or Java. Java. I really like how that sounds. I'm not making fun of anyone when I say Java. Java. I think it sounds cool. So in our last episode, we talked a lot about variables. We delved a tiny bit into some comments and the Java docs and such like that. In this episode, we're gonna talk. After last episode, I kind of felt like we really kind of need to address in a bit more detail how memory works in Java and almost every programming language. So let's jump to our whiteboard or our blackboard, I guess. So first thing I want to explain, so we've learned that you can initialize a variable by specifying one if it's public, private, or the default or protected, right? So like if we wanted to have a public variable, and I need my pen. So if we want to have a public variable, for example, public, public, and let's just make it an integer and call it my age. So what this is actually doing, I know in most places you look, it says, oh, this creates a section in memory called my age. And that's not entirely accurate, because what it's actually doing, when I do this, it's saying, okay, I'm creating a variable, or we've always said it creates kind of this little box. And it is creating something in memory. This box actually is in memory. This box here is called my age, right? But this box actually doesn't have anything really in it at this point. Now when we come in here and so this is the declare, right? declare, and then we initialize. itialize. So this is the initialize phase, and up here's the declare phase. So when we initialize it and we say my age equals 45, right? This is not actually putting into this box my age equals 45. What this is doing is in another area of memory where it actually is keeping all this information. So let's just pretend we talked about memory addresses, right? So if we're just gonna do it, let's just do kind of just to explain it. Let's kind of do it as, this is not really accurate, but just to help explain it, I think this will actually help. But if we kind of did this like a grid, and what we're going to say, for example, is this is actually, because this is an integer and integer is 8 bytes, this section right here is basically, you know, where we draw our lines like this, and 1 2 3 4 5 6 7 and 8 maybe. So this little section that we've drawn up there basically contains the full, you know, 8 bits binary blah blah blah. That's what this is. And this is just to make it easier to understand. So let's say, for example, we're just going to number these 0, 1, 2, 3, 4, 5, and 6. Let's just do that. Boop, 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 like that, and like that. That's an ugly 6. And then we'll just do 0, 1, 2, and 3. Okay, so here we have kind of our little grid that's kind of representing our memory. And what we're doing is, let's say this 45, the program finds some memory and it puts the 45 right. Oops, that's a 54. Let's undo that. Let's do a 45 right here. So what's actually saved in this variable is the address. So it would be like a 0x, which means it's a hexadecimal value, and it's on row 2 and it's down 3. So this is just an example, right? So what this is doing is saying my age is stored at 0x23. And then anytime we access my age, it knows to go look at the address of of memory that contains our value, right? And we're actually going to show you this. I've got some C++. I'm going to show you kind of what this is actually doing. So here we go. We've got our my age. Now, in order to understand some more of this, we have to talk a little bit about scope. And in Java, especially here, and C#, C++, and various other ones, when we've what's one of these that has a bit of stuff in it? I think the private access one, limited access. I think this had a bunch of stuff in it. So if we come in here, so as we can see, we use these brackets. Now these curly braces, curly brackets, whatever you want to call them, these are what you can define a block of code. For example, as you can see, when I'm in Eclipse, if I mouse this one right here, we can see it highlights that one. So it's saying that this is a block of code. Then if we have down here, we have a little subroutine, and we mouse over that one, you can see this is its block of code. So what I kind of want to explain here is if, for example, we have a function that we're passing our value to, and we're not returning it. So let's say we have a, let's just say public, P-U-B-L-I, public, and it's going to not return anything, so it's a void, and we'll just call it add. Oops, we probably should do that lowercase. Let's just erase it. Okay, and then add. A-D-D, and it's going to take in an integer called my age. And then we have our little curly brace. And we have our closed curly brace down here. So an important thing to understand is this my age and this my age is not the same thing. And one way you can kind of tell that is because here we're declaring a variable. Here we're also declaring a variable. So what we're doing when we call this, and like if we say, here we're actually calling it add, and then we do parenthesis my age, close parenthesis like that. So what we're doing here is we are assigning by value my age. So what this is actually saying is this my age right here, which is not this my age right here, because this is a new variable being created used in this scope. Now the thing about scope or blocks of code is everything that's declared within them is not visible to those things that are outside. And like I said, we're going to get into this using C++ in just a minute, but I just kind of want to get this idea down real quick. So this my age, this is, let's just call this in our main, M-A-I-N, right? This is our main my age, and then this will be our method, M-E-T-H-O-D. This is our method my age. So the thing you want to understand is when we're doing this, we're passing 45 into this my age. This, once again, is declaring a new spot of memory. So let's just say, for example, this is going to be this spot right here, which is 41. So it says 0x41. So, and then we're saying that here we're assigning my age, which is 45. So this is actually going to pass into our program the number 45, right? So this guy now gets the value 45, assigns it to its memory location, and then if when here we say, whoops, that's an uppercase, M-Y-A-G-E, and we do a plus plus, this is now going to take the my age that's at this location, it's going to change it to 46, right? And notice it's not changing this my age down here. So now my age inside this function gets turned to 46. Now when it hits this end bit of code, when it says the code's over and this loses its scope, basically the next sweep that the garbage collector, which is kind of a memory thing, it just goes and looks through memory, making sure everything is being used. If it's not, it goes and deletes it. So if in our next thing we said print, and I'm not going to do the actual syntax here because I don't have space, and say my age, M-Y-A-G-E. So if we told this to print my age next, it would actually say, oh, my age is this location, and it would point down here. Now there's a good reason I'm explaining this, and let's go into C++ real quick. So here I have a little program that doesn't do much other than kind of shows you what exactly is going on here. So what we're going to do is we're going to debug this guy. So I've put this is our main. Like we've said, almost every programming language has a starting point, and that starting point is main. So this is our starting point of the program. The first thing it's going to do is it's going to initialize my num, or it's going to declare my num, and then instantly it's going to initialize it to the value 127. So let's go ahead up here and hit run. Oh, where's my build error? I don't know if my C++ in Visual Studio is configured quite right, because it seems to be having a lot of errors. And we're getting all this it's like all the libraries aren't associated or something. I'm not sure. Maybe let's try something. Maybe if we went here, said new project. Maybe if we just did a new project and then pasted all this code into it, it would work. Actually, before we do this, let's go ahead and do Control A, Control C, and then I'm going to paste it into Notepad++. Because I was getting some other errors a minute ago. So let's go ahead and close this. I did this on my laptop to design it. Okay, so there's that. Let's go ahead and do new project. And we want a C++, just a console application. That's fine. We'll just put it there. That's fine. And then we'll just call this mem test and say, okay, let's see if this will work better if we do it this way. System IO threading, it seems okay. All right, so then if we come here, I just want to make sure I grab all the right stuff. And I need to put, there's the main. Actually, this is a Windows. I'm not sure it's going to work in here right. All right, hold on. I need to stretch this out because it's really compressed. I can't see what's going on. Okay, so we have our using, so we need that. Using namespace and Actually, let's do it right. Might as well do it right. Let's go back here again. Project. I apologize for this. I just need a standard. Why is it? Now the thing is, on my laptop, I was using 2017 version of. Oh, this is C#. Maybe that's part of it. I'm a dummy. Okay, C++. There we go. Maybe this will work. 32-bit console application. That's what we want. Okay, we'll just call it mem test 2. Oops, test 2. Welcome to window application. Let's just finish it. We just want a base one. We don't care about a lot of the fancy bells and whistles. Okay, this is more what I was expecting to see. So now if I copy Control A, Control C, and then Control A, Control V, let's see if this works better. Although, why are we getting an error on that? Control Z real quick. Let's see what it's first. std. All right, I'm not going to include that part then. Fine. Control C. I don't know why it's not liking V. Let's see if that works. Okay, that might work. So let's go ahead and pull this guy back away. And let's go ahead and put our thing in there again, and let's see if we can run this. And we're not getting any errors, so hopefully this will run. I don't know if it doesn't. Okay, so it looks like it's running. Here is our little window, but we don't need that. What we're going to do is we want to actually see the memory that's going on. So what we can do is come under debug here, and then we can go under Windows, and we can say memory, and we just want the first memory. So this is memory. These are the memory addresses right here, and this is what that actual value turns into. Now it's important to note that this is actually 1 byte of memory, and at some point maybe I'll talk about this is hexadecimal, which is 16 base 16, where binary is base 2. So this value right here actually is, whoops, I did that wrong, is an entire byte of memory. So basically when we're talking about an integer, we're talking about 4 of these, which is 4 bytes. So first thing I want to do is, as you can see down here, these are our watches. So we're following something called mynum. So as you look here, we can see mynum is 127. Right now, mynum has junk in it. If we don't know where that location is just yet, but you can see mynum has not been set to 127 yet. But if we go ahead and go into this, you'll see now mynum gets the value 127. Now, I needed to do, let's do this real quick. In other words, we're just going to get a lot of extra junk we don't see. This is all put, this cout stuff is actually printing to the screen information, and we do not want that. So if we highlight that, go under edit here, oops, that's Photoshop. I have all my windows stacked so I don't have to move them around. If we go to edit here and find and replace, we're just going to go ahead and do a replace in files. No, we just want to do a quick replace, and we just want to find any cout, and we're going to replace it with, is that how this one works? We're going to replace it with //cout. So it's going to comment out all those couts. Place all. So now you can see all those couts should be commented out, and we're going to run it again. So once again, we're at this state where we're looking at memory. If we scroll down, this question, I believe this is new with newer versions of Windows and stuff, but this is actually protected memory. It's not actually in our program. And so we can scroll down this for a while. I have 16 gigs of memory, so it might take a long while. But as you can see, what I want to point out first is right now we have created our variable mynum, but it has junk in it. So there's nothing of importance in that variable. Right now it has the value of negative 123, about what is that, 85 million? And so it knows that it's 4 bytes worth of data that it needs, because it's type int, but it just has junk in it until we actually assign it a value, which is right here. We could just hit F11. So now it has 127 in it in hexadecimal, which I believe is like F7. So it'll be F7 and then I think 0000 and 00. So the next thing we're doing here is this little guy right here is saying I want a pointer. Now Java does not have a pointer because it's not actually talking to memory directly. So what we're doing is we're creating a pointer called, it's an integer pointer called p mynum. So it's pointer mynum, and right now it has just a bunch of C's in it because it doesn't really know where this is. It hasn't gone to associate it until this goes and says, and I'm pointing to the address. So the ampersand here is saying the reference. I want the actual address that this is pointing to. So we hit F11, we can see now we got a value in here. And if we click on this twice, we can get that address, copy, and we can paste it up here and V, and then hit enter. Now you can see here is our value right here, because we're 00 FA FD F8. So 00 FD F. So that is this chunk of memory right here. And as you can see, like I said, it has 7F. I said F7, but 7F 000000. And then this CC stuff is just how it reserves new chunks of memory. Now, what we're going to do is in our program right here, what we're going to do is we're now going to increment my num. So we're passing into this increment function or increment method my num. And this is what I really want you to see. So if we go here, you'll see that now it's going up here and it's saying, oh, I have a new function. Now, this is actually slotting out a chunk of memory, and we'll actually see that in a minute where it's going to put my num. So what we're going to do is we're going to get a pointer to this new value my num, and you'll see it's going to be different than this pointer right here. So let's go ahead and hit F11, and you can see here that this memory location is 00 FAFCE. And if we kind of go up, I bet, usually if you go up, you can see it's right here. This is the reference to that memory. So you have the, and the way it works in memory, it's called, I can't remember, it's either Big Indian or Little Endian, not Indian, Endian. And it's kind of backwards. So as you can see, this is E8, so E8's there, FC, FC's there, FA, FA is there, and 00. So this is pointing to our new memory location for where our new 127 is at. So let's go ahead and continue again, and we will see that we've finished it. We've added 5 to it, and I think I just missed where that actually is. So if we find this memory location, we'll see, copy, we'll see here that this one now has the value of 84, because 7F plus 5, which is what we did, we added 5 to it, makes 84. Which, like I said, this is hexadecimal, so this is actually in the 4 is in the 1 place, 8 is in the 16th place. So it gives you 132. So now we're going to exit. As you can see, we've finished our little method up here. I'm going to try and move this guy down just so we have a little more room to look. Oops, go back up. And maybe lower this guy just a little bit. It'd be really nice if we could actually get our original memory location and that upper memory location at the same time, but no promises. So now we're exiting out of our function. Now what I really wanted to point out here is my num now has the value of 132, where it was, what was it, 127? So, and this might actually be that other memory location right here. So here's our new memory location. Here's our old memory location. If that's it, that's perfect. Okay, so sorry if I'm being confusing. I'm not trying. So here's our new memory location. Here's our old one. So in theory, I think we're going to actually see that we're going to point back to that one at some point. So let's go ahead, hit F11, and you'll see the increment my num is now complete. So it's going to go to the next piece, which is where we are going to do change value my num. And this one's going to be a little bit different. So let's watch. So now we're doing change value my num. Now one of the things that's different about this function is here we're passing in the integer of my num, which is 127. Here, because we have that ampersand in front of it, we're passing the address to where that 127 lies. So if we look here, it's still going to say 127, but it's actually passing in the address. So this will actually say, hey, I want the address, because that's what this says, integer, the address of. So this is passing by reference. So we're passing the address of it. So if we go like that, now we can see that this function is in this little chunk of memory right here, and it's actually part here and stuff like that. That's kind of not important at the moment, but we'll see here we're setting up our new p_num is going to be here. So right now it's finding this chunk of memory, and it's going to say I'm creating a new p_num completely separate from the other one, and this will contain the address of our original my_num. So let's see if that works right. So we have 00FAFDF8, which I don't know. It's a little hard to find that directly in here. So let's just continue on, and we'll just make sure this works right. So now that we have the p_num and this my_num right here, we're going to go ahead and add 5 to my_num. Right? So this once again will take 127 up to, what was it, 132? I can't remember. So now you see we've actually changed that original my_num value to 132. So it was pointing to that location where this guy resides. If we hit next, now what we're going to do is we're going to end our function. We're going to go ahead and say, okay, look, it all worked. And oh, I thought I output. No, actually we don't output, because that goes in through debugging. It gets really irritating. So now you can see our original value, my_num, actually got changed, and that's because we passed in the address of the location of that. So that's kind of like we were saying here. When we did that little ampersand right here, we're saying, I don't want the value, I want the reference. I want the reference to that value. So that would have made this one actually be 23, and it would have changed that value there. So now this actually has some implications that could cause some issues with programs and stuff, because I can access memory directly. I can bypass that, you know, this is no longer private from this, because I can just access the memory location. So Java kind of fixes that issue right there, which is why we say it has increased security. So now let's look at just another little a demo of scope. So we were talking about curly braces, and this is the same in C++. So as you can see here, this is not a method, function, or anything. I just simply have in my code an opening bracket and a closing bracket, saying that this chunk of code is its own. So anything I define within this chunk of code is not related to anything outside this chunk of code. And so now let's go ahead and continue running, and we'll see that now this is going to say, okay, scope is right here. It's set to 7, and this is just simply saying what the address of scope is so we can find it. So, but we can actually see it right here because it's all bright red. It set it to 7, and I used a small number so the hexadecimal wouldn't be so confusing. Although it will when we add to it or something. Actually, no, we don't add to this one. So here you can see scope is set to 7, and that's the value that's saved in that address location. So if we go to pscope and we hit down one more, you can see pscope has that address right there. Now, because I hit the other one, we're actually in the second one where it set up another scope, which is this scope right here, and we're going to set that to 5. Right now it has junk in it, just has all this mumbo jumbo right here. But when we set that, we actually initialize it. Oh, actually I was wrong. That was the address pointing to it. Here's the 5 right here. So up here, where was that 7? 7 is right here and 5 is right here. Now one thing to note is memory doesn't, it's RAM. It's random access memory. It doesn't necessarily do it sequentially. It just does it wherever it has room and however it wants. It handles all the, I know where this thing is and that. So as you can see, this 7 is actually before the 5. If we ran this program again and many other times, we would just get random locations that our memory is going to be stored. So let's continue on. So now what we're doing is we set this chunk of scope to 5. Now what I wanted to point out is we have the exact same name. The only difference is this is inside its own little brackets. So this scope is not this scope, even though they share the same name. Now the other thing is once this leaves once it leaves the scope of this code block, this is up for grabs. It could be taken by the garbage collector, or another chunk of another part of our program could use this same piece of memory. You know, it could actually use maybe that for a new integer. So these 3 and that 1. It doesn't have to be the same one. So let's go ahead and continue, and we'll see that we got to our very end of our program. Now it's going to try and do return blah blah blah. But hopefully this helped you understand. I know it's really kind of complex and hard to understand, but hopefully this kind of helped you understand the concept of scope. Where did my Photoshop go? There it is. So I think we're at 31 minutes, and I think this is a whole lot to chew on. So as always, if you have any questions, feel free to leave comments down below. Ask me questions. If I miss something, I'm like I've always said, I'm not perfect. I'm not you know, the absolute guru at all this stuff. I just enjoy it. So I can learn too from you. So if you have any input that you want to share, or any questions you have for clarification, leave them in the comment section down below. If you enjoyed this video, found it even remotely entertaining, educational, whatever, leave a thumbs up down below. Aside from that, comment, like, and subscribe. Follow me on Twitter. Check out my Discord and my other channels. And that's it. Until next time, I'll be seeing you later. Bye.